Welcome back to the channel. Today we're going to be doing a bit of a deep dive into cloud protection and cloud block in Microsoft Defender. It's an absolutely brilliant feature which is not discussed enough. So let's dive in. First, what is cloud protection? Cloud protection is the ability to block malicious software that hasn't been previously identified, like newly released malware or zero-day viruses. Now, this isn't a brand new feature. In fact, it's been part of Defender for almost 10 years. The best part is you don't need a P2 license either. It's included in Defender by default. So why am I doing a video on a decade-old feature? Well, because most organizations aren't using it to its full potential. To get the best protection, you need to understand what it does and how to configure it properly. So let's break down some of the key settings and how they work together. When Defender encounters an unknown file and it can't determine the safety based on the hash, it may request a sample for cloud-based analysis and detonation if needed. There are a few user configurable settings here. First, do not send samples, which is the least secure option. If Defender can't analyze a file, it can't block it. Always prompt, which asks the user for permission before sending the file. Send safe samples automatically. This is good for non-sensitive files like BAT, DLL, or executables. If the system detects potentially PII information, it'll prompt the user. And finally, send all samples automatically. This is my recommended option for maximum protection. Next, Cloud Block Timeout. This setting controls how long Microsoft has to detonate and analyze a file before allowing or blocking the file. By default, it waits 10 seconds, but you can extend this by up to 50 seconds, giving you a maximum of 60 seconds of analysis time. Next, Cloud Block Level. This defines how aggressively Defender blocks unknown executables. Here are the options. Default, which is balanced detection with minimal false positives. High, stronger detection, optimized for performance. High plus, extra layer of protection, but may impact performance and increase false positives. And finally, zero tolerance, which blocks all unknown executables. Now you may ask, how exactly does Microsoft differentiate between these levels, between high, high plus, zero tolerance? Microsoft doesn't publish the exact science behind this, but here's what we do know based on documentation and observations. During the analysis and detonation phase, if Microsoft can't make a final determination on a file, it assigns a confidence score, a percentage representing how likely the file is to be malicious. Here's a practical example. Let's say Microsoft assigns a file an 85% malicious confidence score. If your endpoint is configured with a high level, the file might still be allowed to run, since the confidence threshold for blocking hasn't been met. However, if you've configured the setting to high plus or zero tolerance, the same file would most likely be blocked, because those levels are more aggressive in blocking suspicious content. This is why block level tuning is so important. It gives you flexibility to balance protection and usability based on your environment's risk tolerance. Another major advantage of cloud protection is that once a file has been fully analyzed and determined to be malicious, Microsoft only requires the metadata from a client with a hash to block the file, thereby blocking it for all customers with cloud protection enabled. So what's the recommended level? Well, it depends on the endpoint and what it's used for. For example, domain controllers. I'd typically go with zero tolerance. You don't want unknown software installed on them. Most user devices, I'd recommend high or high plus. Developers, IT staff, they may need a more relaxed policy due to testing unknown files. The bottom line is avoid a one-size-fits-all approach. Tailor settings based on the role of the users or the devices. Now that we've covered the architecture, let's jump in and see how all of this works in practice. Okay, let's try and bring this all together. When an endpoint encounters a file for the first time, it'll first compare it to the local signatures. The next step is to send the file metadata to the cloud and compare it to known files. All of this takes an extremely short amount of time, normally less than 2 seconds. It's important to note the cloud block timeout starts as soon as the metadata has been uploaded. If the cloud protection is still unable to determine if the file is safe to run, it'll request a sample of the file. This request will comply with a safe sample configuration. The final stage is a combination of the block level and the timeout factors. If the final analysis is complete before the timeout period expires, the file will either be blocked or allowed. If the analysis cannot be complete in time, the file will be given a risk-based percentage score, which will determine if the file is allowed to run or blocked. All of this is based on the cloud block configuration level. Okay, let's set this up in the security portal. In the security portal, go down to Endpoints and Configuration Management and Endpoint Security Policies. Next is to create a policy, and our platform will be Windows 10, 11 and Windows Server, and the template will be Microsoft Defender Antivirus. We will give it a name, and you can add a description. So the important settings is allow cloud protection. You want to turn this on. We scroll further down. We have the cloud block level. So you can set this to default, high, high plus, or zero tolerance. And underneath that you have the cloud extended timeout period. So we'll turn that on. Important to note that whatever time you put in here adds to the default 10 seconds already configured. So we can put a maximum of 50, which will give you a 1 minute timeout period. As you can see, you can't actually go above 50. Finally, we need to look for sample submissions, which is a bit further down. And as you can see, we can configure them to always prompt, send safe samples, never send, or send all samples automatically. Click Next. You can assign it to any groups. In our scenario, we will assign it to all devices. Click Next and save, and that's all done. And that's it. Hopefully you found some of the information useful, and I'll see you next time.